Imagine this. Everyone on Earth gathers in one place. Picture a vast field stretching as far as the eye can see, filled with people from every corner of the globe. Different cultures, different backgrounds, all united for one singular event. We all count down together. 3, 2, 1, jump! The anticipation builds as the countdown begins. Hearts race and a collective breath is held. The moment arrives and billions of feet leave the ground simultaneously. What happens next? Do we throw the Earth off balance? Do we trigger earthquakes? The ground beneath us trembles, but is it enough to make a significant impact? Could our combined weight and force actually cause the Earth to shake? Does the planet change its orbit? Could this massive, synchronized jump alter the very path our planet takes around the sun? The idea seems far-fetched, but let's delve deeper. It's a question that sparks curiosity and maybe a little fear. The thought of billions of people jumping at once is both fascinating and terrifying. What kind of power do we collectively hold? Let's explore the science behind this grand, hypothetical jump. Scientists have pondered this question, using physics and mathematics to predict the outcome. It's a complex problem, but one that can be broken down and understood. It sounds like something out of a sci-fi movie, right? The idea of a global jump is reminiscent of scenes from futuristic films where humanity unites for a common cause. But this isn't just fiction, it's a thought experiment grounded in real science, a single, coordinated leap by billions of people. Imagine the sheer scale of such an event. The logistics alone are mind-boggling. But if we could pull it off, what would the actual impact be? Could we, as a species, make the Earth itself tremble? The force generated by billions of people jumping at once would be immense. But would it be enough to cause noticeable seismic activity? Let's consider the numbers. It seems impossible. But physics can help us figure out what would really happen if everyone jumped at once. By calculating the combined mass of humanity and the force of the jump, scientists can estimate the potential effects. While the idea is intriguing, the reality might be less dramatic than we imagine. The combined mass of all humans is roughly 500 million metric tons. When we jump, we exert a force on the ground. However, the Earth is incredibly massive, weighing about 5.97 sextillion metric tons. The difference in scale is astronomical. When we land, the force is distributed across the entire surface of the planet. The Earth absorbs this impact with barely a shudder, the energy dissipates quickly, and the planet continues its journey through space, unaffected. So, while the idea of everyone jumping at once is a fun and thought-provoking concept, the reality is that our planet is far too massive for us to have any significant impact. It's a humbling reminder of our place in the universe. In the grand scheme of things, we are but tiny specks on a vast, resilient planet. Our collective actions can shape the world in many ways, but making the Earth itself jump is beyond our reach. And perhaps that's a good thing. Let's get down to basics. Physics is a fascinating subject that helps us understand the world around us. It explains how things move, why they move, and what forces are at play. By understanding the fundamental principles of physics, we can gain a deeper appreciation for the natural phenomena we observe every day. One of the most important principles in physics is Newton's third law of motion. This law states that for every action, there is an equal and opposite reaction. This means that whenever an object exerts a force on another object, the second object exerts a force of equal magnitude in the opposite direction on the first object. Let's take the example of jumping. When we jump, our muscles contract and exert a force on the ground. This force is directed downward, pushing against the surface we are standing on. The ground, in response, exerts an equal and opposite force upward, which propels us into the air. This upward force from the ground is known as the ground reaction force. It is this force that allows us to lift off the ground and experience the sensation of jumping. Without this reaction force, we would not be able to leave the ground, no matter how hard we tried. This is how jumping works. It's a simple yet powerful demonstration of Newton's third law in action. But the principles of physics don't just apply to small-scale actions like jumping. They also help us understand much larger phenomena, such as the behavior of our planet. Now let's think about the Earth. Our planet is a massive object, much more massive than any living creature or human-made structure. Its mass is so great that it exerts a significant gravitational force, which is what keeps us anchored to its surface. Our planet is massive, much more massive than all of humanity combined, like really massive. To put it into perspective, the Earth's mass is approximately 5.97 x 10, circumflex 24 kilograms. That's a number so large it's almost impossible to comprehend, but let's try to break it down. Imagine comparing an ant to an elephant. The difference in size and mass is staggering. Now take that comparison and multiply it by an even greater factor. The Earth is like the elephant, and we are like the ants. Or think of a grain of sand compared to Mount Everest. The scale is almost unimaginable, but it gives us a sense of just how massive our planet truly is. This immense mass of the Earth has a profound impact on everything around us. It creates the gravitational force that pulls objects toward the center of the planet, giving us weight and keeping our atmosphere in place. It also influences the orbits of the moon and other celestial bodies, playing a crucial role in the dynamics of our solar system. The gravitational force of the Earth is what keeps the moon in its orbit, creating the tides and influencing the behavior of the oceans. It's a delicate balance that has been maintained for billions of years, allowing life to thrive on our planet. Understanding the concepts of force and mass not only helps us appreciate the mechanics of everyday actions like jumping, but also gives us insight into the grand scale of the universe. It reminds us of our place in the cosmos and the incredible forces at work that shape our existence. So, the next time you jump, take a moment to think about the forces at play. Remember that you are experiencing a fundamental principle of physics that governs everything from the smallest particles to the largest celestial bodies. It's a powerful reminder of the interconnectedness of all things and the beauty of the natural world. Let's talk numbers. The average person's jump exerts a certain amount of force. Multiply that by billions of people, and we get a really big number. But then we have to compare that to the Earth's mass. And that's where things get interesting. Even with all of us jumping together, the force we generate is minuscule compared to the Earth's mass. It's like a fly landing on a train. The train might wobble slightly, but it's not going to derail. So, if we can't move the Earth, what can we do? Would our jump cause earthquakes or tsunamis? The answer is, probably not. While our collective jump would create a tiny seismic wave, it would be far too small to be felt, let alone cause any damage. Think about it this way. Earthquakes release enormous amounts of energy stored within the Earth's crust. Our jump, in comparison, would release a tiny amount of energy. It's like comparing a firecracker to a nuclear explosion. Section 5. Beyond the jump, exploring the cosmic consequences. In this section we delve into the fascinating and often mind-boggling implications of our actions on a cosmic scale. The universe is vast and complex, and even the smallest actions can have ripple effects that extend far beyond our immediate surroundings. But what about the Earth's place in the cosmos? Our planet is just a tiny speck in the vast expanse of the universe, orbiting a relatively average star in one of the many galaxies. The Earth's position and movement within this grand cosmic dance are governed by the laws of physics, particularly gravity. Would our jump affect our planet's orbit around the Sun? This question might seem trivial at first, but it touches on fundamental principles of physics and our understanding of the universe. The Earth's orbit is a delicate balance of gravitational forces primarily between the Earth and the Sun. The answer, once again, is no. Despite the collective force of billions of people jumping simultaneously, it would be minuscule compared to the immense gravitational forces at play. The Earth's mass is so large that our combined jump would barely register as a blip. Gravity is what keeps the Earth in orbit, and our jump wouldn't change the Earth's overall mass or its gravitational pull. The gravitational force between the Earth and the Sun is what maintains our planet's stable orbit. This force is incredibly strong and consistent, ensuring that the Earth follows a predictable path around the Sun. Imagine the Earth as a giant spaceship. This analogy helps us understand the concept better. A spaceship, like the Earth, is subject to the laws of physics and gravity. It travels through space, maintaining its course due to the forces acting upon it. If everyone on the spaceship jumped up and down, it wouldn't change the spaceship's course. The spaceship's mass and the forces acting upon it are so significant that the collective jump of its passengers would have a negligible effect. The same principle applies to the Earth. The same principle applies to the Earth and its orbit around the Sun. The Earth's orbit is a result of the gravitational pull of the Sun, balanced by the Earth's velocity as it travels through space. This balance is what keeps our planet in a stable, predictable orbit, ensuring the regularity of seasons and the passage of time. So, while the idea of a global jump is intriguing, it's comforting to know that our place in the cosmos remains secure. We see evidence of this all the time in nature. Every day, millions of things jump, fall, and move around on Earth. Birds take flight, waves crash on the shore, and trees sway in the wind. Yet the Earth continues to spin on its axis and orbit the Sun without any noticeable disruption. Scientists even use sensitive instruments to measure tiny vibrations in the Earth's crust. They can detect earthquakes happening thousands of miles away, but our global jump, it would barely register on their instruments. So, what's the final verdict? If everyone on Earth jumped at the same time, the effects would be negligible. We wouldn't cause earthquakes, tsunamis, or change the Earth's orbit. We might create a tiny, undetectable tremor, but that's about it. It seems our planet is a bit more resilient than we might think. Even with billions of us jumping up and down, our impact on the Earth as a whole is surprisingly small. While our hypothetical jump might not move mountains, or planets, it does raise an interesting question. If we can't even make the Earth flinch by jumping together, what other seemingly impossible feats could we achieve through collective action? Food for thought, isn't it? Now, just for fun, let's imagine jumping on other planets. What if we all squeezed onto a tiny asteroid and jumped? Would we send it hurtling through space? What about a planet with weaker gravity than Earth? Would we be able to jump higher and maybe even make it spin a little faster? The possibilities are endless, and the science behind it is just as fascinating. Keep those what-if questions coming. The universe is full of wonders waiting to be explored.